Hey, I'm Corey, and I've been writing Rust in my free time for a few years and recently started streaming some of my coding. And this year for Advent of Code, I thought it would be fun to make a video series of solving each puzzle. These videos will be the first time I'm seeing the puzzles, so you'll get to see how I solved each puzzle in real time. Hopefully you enjoy these videos, as I'm excited to make them. Let me know what you think in the comments below. Okay, so let's go ahead and get started with day one here. Day one is called Calorie Counting. And since we don't have anything set up, let's get some stuff set up in our repo here first. So we're going to make a new file, a cargo.toml file, and we're going to say that this is going to be a cargo workspace. And what that means is that we're going to be able to have multiple crates in this workspace, and they're all going to be able to work together. It's kind of like a mono repo style, and I like doing that for my Rust projects. So now that we have that, we can do a cargo new to create a new binary. We're going to call it calorie counting, and we're going to name it calorie counting. So the directory is going to be with a 0, 1, and the name of the crate should not be. And then the last thing we need to do is we're going to add it to this members array that we just started. You can see Copilot suggesting the wrong thing there for us. We'll ignore that. And actually, we're going to turn off Copilot for this. Disable globally. Because we're not going to use them for these videos. Okay, so we got calorie counting, and now if we do cargo run, we can see the hello world that came from here. So now we at least have a place to start writing code, and let's go read the question here, and we will go from there. Santa's reindeer typically eat regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. For that, their favorite snack is a special type of star fruit that only grows deep in the jungle. The elves have brought you on their annual expedition to the grove where the fruit grows. To supply enough magical energy, the expedition needs to retrieve a minimum of 50 stars. Okay, so this is just telling us about the stars. Collect stars by solving puzzles. 2 puzzles will be made available on each day. Each puzzle grants 1 star. Good luck. The jungle must be too overgrown and difficult to navigate in vehicles or access from the air. The elves' expedition traditionally goes on foot. As your boat approaches land, the elves begin taking inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying. Your puzzle input. The elves take turns writing down the number of calories contained by the various meals, snacks, rations, etc. that they've brought with them. 1 item per line. Each elf separates their own inventory from the previous elf's inventory, if any, by a blank line. For example, suppose the elves finish writing their items' calories and end up with the following list. This list represents the calories of the food carried out by 5 elves. The first elf is carrying food with 1,000, 2,000, 3,000 calories for a total of 6,000. The second is just this 4,000. The third are the 5 and the 6. And then, the fifth elf is carrying 1 piece of food worth 10,000. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, that's 24,000 calories carried by the 4th elf. I think that's this one. Find the elf carrying the most calories. How many total calories is that elf carrying? Okay. So now we read all that, and the first thing I'm going to do is I'm going to take the example input, and we're going to put that in a file here. We're going to call that example.input. Okay, and now we're going to start using that in here. And I think what we're going to want to do is we're going to create a let for the puzzle input. Or I guess here we're going to do, this is the example input. And we're going to use include string in Rust. And that's going to take this file at compile time and just include it actually in the binary. And so we're just gonna take it and let's just print it out here. And we can print it out by putting the variable name in the squiggly brackets in put. Can't type. And then if we cargo run this, we should see nothing. Why do we see nothing? Oh, because we didn't put anything in the file yet. Copy. Actually put things in the file, cargo run, and there we go. Now we are seeing the contents of the file printed out, but let's actually start parsing it. So the puzzle talks about how we have pieces of food that have a calorie value, and we have elves that carry pieces of food. So let's just write some structs to start modeling that out. Structs hold data in Rust. So let's make a struct called food. And it has one field. It has a public field called calories. And it's a like U64. A big number. I don't think we need to care about what type of number it is for the moment, so we'll just make it a U64. And then we have another struct called an elf. An elf. There we go. And they have a public thing that's, we're just gonna call it foods. Foods already plural, I think. And it's going to be a vec of our food items that we just made. A vec is going to be a growable kind of array in Rust here. So now that we have these structs and we have our input, we're going to try to start parsing things out of our input. So let's do, our example input is a string. So I think the first thing that I want to do is I want to split it up by the elves. And it's split up by 2 new lines in a row. So we can do, let's make a new variable for split by elf, which is going to be, we're going to take our example input and we're going to split it on a pattern. And our pattern here is going to be new line, new line. So then that is going to give us an iterator that we can hop over. Or in our case, what we're going to do is, I think what we want to do here is, now that we have them split by elf, we want to actually create a new elf from each individual little segment here. Because actually here, let's go one step at a time. For a section in split by elf, we can just debug out the section. Let's get rid of this print line, end with a semicolon. And cargo run, we can see the different sections. So each one of these is the different elves that we're talking about. And actually, the first thing that I notice is that we probably want to call a method on each section to get rid of the new lines at the end. So I think from that we can do, is it a strip or is it a trim? Trim is what I'm looking for. If we trim it, awesome. So that'll get rid of the new lines here. But instead of just calling it in the debug, I think we're actually going to use some mapping. So let's map the trim function. So let's do, we have our section and then we do s.trim. And then I don't need to call trim here. And this should be the same result. Now we're just going to do it by mapping over the iterator instead of doing it in the for loop. And I think we're really just going to move more things into these maps and do less in our for loops. But the for loop is a nice way to get started and see everything here. I also think I can inline trim. Is that what I want? No, that's not what I wanted at all. I was thinking I could replace it without this closure and just call trim differently, but it's okay if it doesn't want to help me with that. And actually, so I think now that we have these strings, I wish there was a method on elf that I could just say parse the string and it would create a new elf for me. So let's do that. Let's write an impl block for our elf and a function called parse. It's going to take in some input. And we're going to say it's a string, and we're going to return a self. We're going to return an elf from that. So now we have our input, and it's going to be one of these sections. So we want to take the foods from inside here. So we're going to take our input, and actually let's do lines. And we're going to take our input, and we're going to split it again. This time we're going to split it on just a single new line, so that we have items of like the 1000, then the 2000, then the 3000. And then from here, we're going to do lines, and let's map over our lines again. Just like we were doing before, we'll make a new closure. This time our variable is going to be called L. So on our that, we can try to parse it into, actually, I think I can do parse where you return a U64, we can use the turbo fisher to tell it what I want to parse into. And we're going to unwrap it. We're going to say that we know it's always going to return a number. And then we're going to collect this into food calories. So I'm making a new variable here. And this is going to be a vector of U64s, because that's what we're trying to parse. And there we go. And if I then do debug here for food calories, and let's add a to-do here, because I don't actually return the right thing. I'm going to listen to the Rust analyzer and use the character instead of the string for the new line here. And I just want to start and make sure that this parse works a little bit. So let's actually start by calling it. So instead of debugging out the section now, let's debug the parsed section, elf parse. The only thing that is now mad is it doesn't know our elf can be debugged like that. And it can't, but we can make it do it easily. We can add a derive for debug. And we also need to add that to our food. And what this is just doing is it's adding basically a nice way to pretty print our structs for us so that we don't have to write it ourselves, which is really nice. So we will be using debugs quite a bit. And let's test that out. So we're gonna see that we get food calories, and it's an array where each one of these is separated out, and they are not strings, they're actual numbers, they're not wrapped in quotes. So far we are looking really good. We can hop into our parse again, and we have a vec of U64s, but what we really want is a vec of food, where food has the calories as a U64. So we're really close here. We have food calories, but what if we just wanted to have food? We could do food calories dot into iterator to make this back into an iterator. And then we can map over the calories. We can call it food calories. That would be a good name for it. No, let's just call it calories. Let's call it calories, and then we can do food. And calories can just be newed up inside of it. Perfect. And then we can collect this. And this, we're going to say, is actually a vec of food. There we go. And we can now debug food instead of food calories. And now you can see that we actually have an array of food items with each have their own calories. So it's nice and modeled out. Okay. Except let's change something up here. We have food calories that we map over to parse the U64s, and then we collect it, and then we immediately call into iterator on it again to make it an iterator. So we actually don't need to go to this vec in the middle. So if we stop making it a vec, and we don't collect here anymore, we don't actually have to call into iter. We can just call map again because it already is an iter still. And then we can just make it into our food and collect it to a vec. And now, down here, we can construct our elf. Why? Oh, I don't think I want to debug it out. That's what was happening. So I didn't like that I had a reference to it and I was trying to return it. And actually, I didn't have a reference to it. Oops. The problem was that I wasn't debugging it with a reference here either. I was actually passing food to the debug macro, and then I couldn't use it again on line 19. So the answer was either to do it by reference, like I am now, or I just actually could get rid of the debug statement, because now it's actually doing what we need it to. So now this debug here is actually going to be pretty printing out each elf in a separate thing, and each elf knows about its different foods that have the calories. So now we have this all modeled out pretty nicely, except the last thing that we want to do is I actually want to say that we want a elves array. This is going to be, oops, we want a vec of these, and so we're going to take some of this. We're going to do split by elf, map trim, and then we're going to map elf parse. Actually, we'll do it this way. Okay, so now we have our elves, and we can debug out the whole thing just to make sure that we're doing it right. Cargo run. It looks like we are. There we go. Okay, so now we have our vector, and back to the puzzle. What we're trying to do is find the elf that is carrying the most calories. And we want to know how many calories in total is that elf carrying. Okay, so each elf then is going to need to know how many calories they carry. So let's give them that method. We can give them a calories method that doesn't take in anything besides a reference to self. It needs to know about itself. And it's going to return a U64. It's just going to return a number. And let's see, we want to do food. That's our self.food. That's the array of foods. And let's just map over that. From each of our food, we want to get the calories out of it, which I think I made public. I did. Awesome. It doesn't like having map because we need to make an iterator first. And then we can map over the calories and we can sum them up. That will return all of the sum of the calories of all of the food items. So now I think what we can do is we can go from our elves, elves dot map dot calories. Oh, that's this again. I need to do iter to get an iterator. And then we can map calories, and I think that should just be able to call max on it now. And we get the answer of 24,000, some 24,000, because there was a max, and it was 24,000, which matches the answer of 24,000. Awesome. So we got the example one working. So let's grab my input. And let's make a new file called my input. And I think what we want to do here is let's rename this function to part 1. And let's have it take an input in actually, which is a string. And we'll go make a new main function. And we're going to move some stuff around. We're going to take the example input part and put it here. And then we can do let example part 1 answer equals part 1 on example input. Okay. And then let's do a print line for example input part 1 answer, and it's this whole thing. I probably could have just debugged it. The variable name is basically what I wanted to print anyways, but that's okay. Oh, this doesn't think it returns anything, which is reasonable, but it is going to return a U64 because that's the answer to part 1. We don't need to debug it anymore. Instead, we're just going to return the max. And this isn't example input, it's just input. And what are you mad about now? Mismatch type. Oh, it says there might not be a max because we might not have any elves. But we're just going to unwrap that error and say, no, we definitely know we're going to have some elves to deal with. And now we can run it. Example input part 1 answer. Is that awesome? We can copy this whole thing, except change this to my input, change that to my, change that to my, change that to my input, and this, my. And we need to, we're not returning the print line. So add the semicolon. Ooh, okay, so we got an error. I think this one's actually pretty easy. I think what I need to do is just call trim on the input here before we start doing it. I bet there's a new line at the end of what I copied. And we just want to get rid of that. Okay, I was wrong. So let's see what we are looking at. Where are we running into our issue? So main line 15. Here. Okay, so it's when we're parsing the number, we got a kind empty. So there's an empty string here, probably. Okay, so let's debug the input that we're getting to this parse method for each elf. Okay, so one of the inputs is just empty string, but I didn't think it should be. What is my... Oh, I didn't actually put the thing in the file, just like I didn't for the example one at the beginning. Probably don't need this debugging line because I bet that wasn't the issue. There we go. Okay, so 69836. 69836. 69836. Submit. There we go. Okay, that is the right answer. So let's make a commit here. Day 1, part 1. We are halfway there. We modeled a struct for the elf and the food. We parsed into the structs and found the elf with the most food calories. Okay, make this commit. Let's commit anyways. We're on the main branch. Maybe eventually we'll make branches, but for now that'll be fine. Okay, and now we can get ready to do part 2. Continue to part 2. By the time you calculate the answer to the elf's questions, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, even if one of the elves runs out of snacks, they still have 2 backups. In the example above, the top 3 elves are the 4th elf, then the 3rd elf, then the 5th elf. The sum of the calories carried by these 3 elves is 45,000. Find the top 3 elves carrying the most calories. How many calories are the elves carrying in total? Okay, so that's not going to be that different, I don't think. And we already have a lot to start with, so let's copy, or let's just make a new function. We don't need to copy it. For part 2, part underscore 2, there we go. Same signature though. Okay, and let's see, we're gonna do, I think I want to parse the elves out the same, so we're just gonna take these 2 lines of code. And now I think though what we want to do is I'm going to let this array be mutable, and I'm going to go elves.sort by key, where from our elves I can do dot calories. So now we're going to sort the array, or the vec, by the number of calories. And then now I want to get, so we're going to sort it by calories, so the top 3, let's just reverse this because I want it to be in the order where the top 3 are here. So now I want to do elves at 0 dot dot 2. I think that will get the ones I want, and I want to wait a sec. Sort by key. Oh, and I actually don't need to. Okay, let's actually do this a little differently. Let's let a calories be a vec of U64s, and that's going to be elves.map dot calories. We don't need that to be mutable. We want this to be mutable. This needs a collect. the reason the map doesn't work right now is because it actually needs we need to call it on an iterator first. Okay. And now what I want to do is do calories.sort. And then I can do calories.reverse. Because now it'll be sorted so that the first 3 calories in the array are the highest ones. So can I just do calories at 0 dot 2 dot sum dot iter dot sum? Yeah, there we go. And I think this will panic if I don't have 3, but that should be fine. Let's take the example, and actually let's do a empty print line here. I just want to add some print line with an empty string. Is that what you would tell me to do? Yeah. Example, and then let's replace that with a part 2, part 2, part 2, part 2. Cargo run. Okay, so the example part 2 answer. Oh, that's 35. That's not the right answer, but that's probably because I actually want the first 3, not the first 2 items. There we go. I just had that syntax wrong. It's non-inclusive. I think I could have done this. Oh no, that's Ruby, not Rust. Wrong language, I think. So that will work for this one. Okay, and if that works for the example input, I have a lot of faith it will work for my input as well. Replace this with part 2, replace that with part 2, replace that with part 2, replace that with part 2. And our answer then is 207,968. 207,968. Submit. And there we go. Awesome. Let's commit that code. Day 1, part 2. Grab the top 3 calories and sum them. There we go. Let's commit anyways. We did for the first puzzle. And let's push that up just to get it pushed. And there we go. That is going to be the first day of Advent of Code. Thank you for joining me, and hope you liked the video. Give me a like and a follow if you did. And check out day 2 coming at you real soon. Thanks. Bye.